Hello everyone and welcome to PC Retro Tech. So in this week's video we're going to be continuing our series on comparing ISA, Visa Local Bus and PCI video cards for DOS gaming. So we're looking at those in this 486DX4100, which has all three types of slot in the motherboard. So you remember in last week's video I compared the ISA and Visa Local Bus cards, and I found that the Visa Local Bus ones were coming out consistently better than the ISA ones. And that's even though we had this fairly rare and expensive Senglabs ET4000AX, which is really reputed to be a very fast ISA graphics card. Now we also had some pretty good Visa Local Bus cards. There was a Cirrus Logic GD5428 and a Senglabs ET4000W32. So my question this week is, can those really fast VLB cards be beaten by a PCI card? Of course, PCI you have a lot more selection, and in fact I actually have a lot of PCI cards to test. It was a standard that went on for much longer, and of course you have more recent cards to compare against. But you have to bear in mind that this is a very early implementation of PCI. I've even heard that it can be unreliable. I mean, this is a 486 after all. So I want to know, is it reliable for DOS gaming? I can imagine certainly for Windows drivers and Windows applications there could be problems, but we're only going to be comparing DOS games and applications here. And can it actually beat the Visa Local Bus, or is it around the same speed? So before I get into the comparisons, I want to update you on a few interesting developments from last week. So the first is regarding this Paradise VGA card, which is a 1988 chipset. I think it's probably manufactured in 1990. And when I received it, you remember it had an incorrect slot cover on it. So this is the original, and you can see that if I align the VGA connector with the hole, it's about 1 centimeter out, and so when I had it screwed in, you couldn't actually screw the card in because it stuck 1 centimeter out the top of the slot. Now, I mentioned that you can't really take a PCI video card or an AGP one and take the slot cover off that, because typically the connectors are around the other way. I mean, if I align them so the D-sub connectors are in the same orientation here, then the slot is at the different end of the card, and that's because PCI cards are this way around. So actually in the end it turned out that it was PCI video card to the rescue. This is a Cheapest Chips S3 Trio. Now I did have to buy it from overseas, and I had to look through hundreds of cards to find one, but I eventually found one that had an incorrect slot cover on it, and they'd just taken an ISA slot cover, this one, and put it on the PCI graphics card so they could move the card on. What they didn't know is that this is a very rare slot cover. Now it was common for very early ISA graphics cards to have the D-sub connector up this far along the slot. But if you look online, it's very hard to find anything that's reasonably priced that has this, and then you're just cannibalizing another very rare, very expensive graphics card. So I was very lucky to find this, and I'll show you the result when we plug it in. So you can see that that matches up perfectly with the slot in this machine. So that's a really nice solution to a very annoying problem. So there were some very interesting viewer comments in the last video, and one in particular I want to talk about. A viewer had a Senglabs ET4000AX in an ISA implementation just like this card, and not only was he getting better performance than this card, but actually better than the Visa Local Bus cards that I tested. Which is a bit of a head scratcher. He speculated that maybe the RAM in this was slow, but this is in fact 17 nanosecond RAM, which is the same. Of course, I'm using a VIA chipset in the motherboard, and these are notoriously slow, although in a video a couple of weeks ago I went through the BIOS settings and made sure that they're all maxed out, and that really actually improved the performance of this machine considerably. So I don't think that's the explanation. The most likely thing is he mentioned he has a turbo jumper on his board, and I suspect that that might be related to the performance issue somehow, some form of early overclocking capability. There's only one jumper on this one, and it's not related to performance at all. It could be the CPU, but I think there's not much to talk about there. I tried this card in a 486 with a write back cache instead of write through cache, and it only made 0.2 or 0.3 frames per second difference in the Quake Benchmark. So the other thing I want to talk about is this V7 Vega card, and I noticed in our benchmarks last week that this performed identically to the Cirrus Logic GD5428 cards. We had two of those, and the performance was identical in all of the benchmarks. Now it actually turns out to be not a surprise, because in fact the chipset used in this V7 Vega is a Cirrus Logic GD5428. Another thing I noticed just recently is that there is some bodge work on this card. I don't know whether this has been repaired or whether somebody has actually modified it to change the performance of the card. I had previously noticed that there was a bodge on the back of the card here, and I don't know what these are for. If anyone does know about whether there is some kind of modification that can be done to these, please let me know in the comments below. So before we get into this week's comparison, let me just recap what we discovered in last week's ISA versus Visa Local Bus comparison. And I think this graph shows it all. You can see all of the 4 Visa Local Bus cards on the right there significantly outperform all of the ISA cards. This is the 3D benchmark, and it was probably the most striking difference between the two kinds of card. In fact, the Visa Local Bus ones are way ahead even of that Senglabs ET4000AX, and it's actually the Senglabs ET4000W32 Visa Local Bus card that is the best of all the cards, and it only just slightly beats all of the cards that had the Cirrus Logic chipsets. So I'll do the PCI cards in batches here. So we'll start off with the Trident and S3 and ATI ones. So the first Trident PCI is this TGUI 9680-1. Then we have a number of S3 Trio 64s. So there's just one that's Trio 64, and then there are a handful that are variations on this. So this is the S3 Trio 64 V2DX, and there is a V Plus. Now these are very common. Again, if you open machines from a certain era, you more than likely will find one of these. In fact, they're so common that I actually have a number of these. So that'll make an interesting comparison again, just between, I think I have 3 of these, to see whether they are all around the same performance, or again if that depends on the implementation. So this particular one is an Elsa Winner 1000 Trio V, and that should be a German brand. And here is, oh, yet another one. So there looks like there's 4 of the Trio 64 V pluses. But this one is a Hercules from 1996 to 97. It's a Terminator 64. So that'll be really interesting because it has a brand name. And then there's the S3 Verge DX, which should again be rather interesting. So this one, if I understand correctly, had some 3D component. This is also a Terminator 3D Hercules from 1996 to 97, according to the label. So it'll be interesting to compare those, although we're not really going to be running applications that are designed for 3D accelerators as far as I'm aware. So now this one's an ATI video card. It's a Mark 64 according to the label on here, a PCI Mark 64 VT, I think. And the chipset, if you can't read that, is ATI 264 VT2. And I know nothing at all about this card, so that'll be an interesting one to compare. Then we have another ATI, and this is called a Wind Charger. Perhaps that's the brand. It's 1996 according to the sticker on it, and it's another Mark 64. I don't see anything that really identifies as the model number here, so if you can see that and you know which is the model number, let me know. But again, this will make an interesting comparison. So in the remaining batch of PCI cards, I have some Cirrus Logic cards, Sanglabs cards. I found another Trident, and then there's everything else. So this is a Cirrus Logic GD54M30. Again, I don't know very much about this card, so it'll be interesting to see how that compares. And I'm also interested just to see whether a Cirrus Logic PCI is better than a Cirrus Logic Visa local bus. They should be about the same, but it'll be interesting to find out for sure. This one is a GD5440, another fairly common card. I think you'll find that in a lot of machines that you open. Here's the other Trident card that I found. I'm not sure why I missed this before, but this is a TGUI 9440-1, and this one says copyright 1994. I don't know whether that's actually when it was produced or not, but anyway, that's another Trident, and we can compare with the ISA ones and see whether they improved at all when they started making PCI chipsets. This is a Sanglabs ET6000. Of course, this is a very high performance card. We know this from other people who've done tests on these, and so it's going to be really interesting to take a PCI version of this. I don't have the additional memory modules here, but I don't think that's going to affect the performance in these benchmarks. So that's the Sanglabs. And I just happen to have a second ET6000 here, but this is a branded Hercules Dynamite 128 video from Hercules, copyright 1996 according to the thing. Again, I don't know if that's when it was built. So yeah, it'll be interesting to compare the brand name version of the ET6000, especially considering they are so highly sought after. I have no idea what this card is. It has what looks like an Intel chipset to me on it, and I've never heard of nor seen this sort of thing before, so that'll be an interesting one to compare. We'll probably find out it's something more mundane when we fire it up, but for the time being, that's the mystery card. There is this Matrox card, and I simply don't recall whether this is a Millennium or something else, so we're just going to have to find that out when we start it up. It just says Power Graphics on it, and it says, I think, IS Storm R2. I don't know whether that's the chipset or not. This one says TVP 3026. So I'm going to have to look into what that is before I power it up. On the back it says MGA MIL2I, I think, so that probably makes it a Matrox Millennium, I would guess. So fortunately we won't be installing drivers for any of these cards today. That just takes an enormous amount of time, and as I'm sure you've seen in previous videos of mine, it's really hard to find drivers for Matrox cards that actually work. So this one, unfortunately, it's hidden underneath what it is, but it says on the back it's a Radeon VE, whatever that is, with 64 megabytes of DDR RAM. So this is really a later card, and you can see it has the heatsink over the chipset there. So this should perform very, very well, but bear in mind that at some point the focus switched from 2D to 3D, and we probably won't be running anything today that can really benefit from 3D accelerators. So some of these 3D cards, although they're quite good for early 3D implementations, they're not great for 2D. So here again is another card that I don't know anything about, and I don't actually even know what brand this is. On the back it just says MVGA, NVT, NT2MP, 32 megabytes. So this could be some kind of NVIDIA TNT card, Riva TNT. I'm really not sure. Being a PCI card, I wouldn't like to place money on that, but we'll have a look when we fire it up and see what it actually is. Yeah, this S3 Trio 64V Plus has slots for additional memory, and in fact they came populated when I got the board. And I decided to try all the benchmarks with those chips taken out to see if it made any difference. And a lot of viewers probably already know the answer to this. No, it makes no difference whatsoever. All of the performance numbers are the same, and you can still run all the benchmarks. So why would you have additional chips like this? And the answer is basically just for the Windows desktop. So if you have more memory, you can have higher color bit depths, or you can have higher resolution. And so I remember watching a video by Phil's Computer Lab about this issue, and he says that his personal preference is to have all the chip slots populated on the boards that he buys online. And I can certainly understand that point of view. So I ran off to have a look at my Cirrus Logic board, and indeed there were no chips in it. So it's possible to just take chips from a donor board and fire it up, but I ran into some problems very quickly. So first of all, I couldn't find Windows drivers for the high resolution modes. That took really a lot of effort to find. And the other issue, which I hadn't expected at all, is that those high resolution modes only work at 87 Hz. And this is too high for most TFT flat screen monitors or LCD monitors. And so the only option really is to use a very old CRT, and even those, it's very, very difficult to get one that does actually work at 87 Hz. And even if you find these monitors online, it's actually hard nowadays to check whether they do support those resolutions. So yeah, it's certainly not going to make any difference for DOS gaming. Even at 640-480, the games are completely unplayable, and so you're certainly not going to want to run them at a higher resolution. So the only real benefit would be for the Windows desktop, and there I can understand putting them in an S3 Trio, because you're probably going to be running that in a later computer anyway, and it is going to affect the resolutions that you get on your desktop. But for DOS games, I don't recommend bothering with the extra chips. It just doesn't make any difference at all. So I have been having some weird artifacting on some of these cards, and because I haven't had any trouble with these cards in the past, I am beginning to think that the PCI implementation might actually be responsible here. So I've put the Cirrus Logic GD5440 card in, and this is what happens. It gives a characteristic set of beeps to tell me that the video card is not working, but then it boots up anyway. I've actually tried it in the other slot, one of the other PCI slots, and the same thing happens. And sometimes it doesn't boot at all, and it gives a faster set of beeps, the same code, but basically just at a faster speed. So I don't know what this is actually telling me. I'm going to go ahead and do timings for the card anyway, since it does seem to actually work. But I am getting also weird artifacting with this card as well, even in text mode from time to time. So there's clearly something wrong here, and I suspect it really is the PCI implementation. So this is what the GD5440 looks like when it's running in the 3D benchmark, and you can see that there's really severe artifacting here. So I'm not going to really persist with this card. I'm going to skip it because it's clearly not working in this slot, and we'll move on to the other ones. So I've got the ATI Mark 64VT card in there at the moment, and it's working on some of the benchmarks, but let me just show you what happens when I run 640-480 benchmark. This is Chris 3D. Takes a couple of seconds, and then it resets the machine. So yeah, I'm having quite a lot of problems with many of these cards in these PCI slots. So let's take a look at the results, and let me just start by saying that the only cards that actually worked in all the benchmarks were the S3 cards. So there were actually 8 S3 cards in total. I've only shown 4 here because there were 2 Trio 64s and there were multiple Trio 64V pluses. So I've just collapsed those into single columns. In fact, one of the S3 Trio 64s was the same speed as the Trio 64V pluses. So I've only included the slower of the 2 Trio 64s here. 3 of the cards were removed because they didn't run at all in the machine. That was the one with the Intel chipset and the 2 with heat sinks on them. These are obviously much later cards. One was 32 megabytes and the other was 64 megabytes, and they're just not going to run in a 486. So I've just removed those entirely. The other one that's not here is the Cirrus Logic GD5440, and the reason for that was, as you saw, it was just severely artifacting, and I couldn't even read the scores that it was giving, so there was no point in including that one. So many of the cards didn't work in all of the benchmarks. There were either artifacts, or the machine rebooted, or there were diagnostic beeps, or there was severe artifacting going on. So I have included all the ones for which I could actually get scores, but bear in mind that really only the S3 cards and one of the Senglabs cards, the Hercules one, actually completed all the benchmarks without any errors at all. So it's really unusual that all of the S3 cards had no problems. I mean, there were 8 of those cards, so it's a pretty good sign that if you have a very early PCI, you might want to consider getting an S3 card, which is really great because they're very cheap and easily obtainable. And they all had roughly the same performance, so it seems it doesn't matter what you get, you're going to get a reasonable result. So the thing that surprised me the most about this first benchmark, the 3D benchmark, is the Senglabs card, how slow it is. That Hercules one was 47.6 frames per second, which made it easily the slowest card. And this is really remarkable because Senglabs ET6000 are highly sought after as being really good cards. But there is more to this story, so just stay tuned. Most of the other cards are either just slightly faster or just slightly slower than the Cirrus Logic Visa Local Bus cards. And I'm not sure that you would really notice the difference between any of these scores. They're all so close to one another. But it does show that PCI and Visa Local Bus were all about the same speed. So this is the Chris 3D benchmark, and the graphing software has unfortunately cut off the bottom of the graph, so the differences are greatly exaggerated. But you can see that the fastest of the Visa Local Bus cards, the Senglabs ET4000, is equal with the fastest PCI cards here, so there's no real difference. If you've got a good PCI card, it'll be the same. And similarly, the slowest Visa Local Bus cards are about the same as the slowest PCI ones. Again, that Senglabs ET6000, the Hercules one, is quite slow, especially compared to the other Senglabs ET6000. And you can also see that the Trident cards are pretty slow in this, but most of the S3 cards are actually going as fast as any of the other cards in the benchmark. So the S3 ones look like very good cards in an early PCI slot. So the Chris 3D benchmark also runs at 640/480, and there were 3 cards here that didn't finish. There was the ATI Mark 64 VT, which just reset the machine when the benchmark was run, and the ordinary Senglabs ET6000 pretty much did the same thing, although there were some diagnostic beeps before it did it, which is a bit unusual. And the Matrix Power graphics adapter, it did actually run, but you couldn't see the benchmark running and you couldn't read the results at the end. So this seems to be basically unusable for this 640-480 benchmark. You can see that the Visa Local Bus cards, the fastest one was the same again as the fastest of the PCI cards, which were once again S3 cards. And the Hercules Senglabs isn't that far behind, but it's still again the slowest card in the lineup. So for the PC Player benchmark, the story is pretty much repeated. The fastest Visa Local Bus card is equal to the fastest PCI cards, and the rough ranking is about the same, with that Senglabs ET6000 Hercules card being the slowest at 11.9 frames per second. So I won't say very much more about this one. Let's have a look at the 640-480 benchmark. Here the story is a little bit different. What you can see is that the Senglabs Hercules card is actually now the second fastest card in the lineup. And a very surprising result, the Matrox Power Graphics Adapter is 6 frames a second, and so was the fastest of all the cards. So here, of course, the Senglabs ET4000 W32 Visa Local Bus didn't actually run this benchmark because of the Visa BIOS issue. And there are a couple of other cards here that reset the machine or reset it with beeps. So most of the cards that are left are all around about the same speed, this 5.1 frames per second. And it's quite interesting how the exact same speed is achieved by all the cards, and you think, well, that must be some kind of limit. And then two cards just pop out of nowhere and suddenly give even better performance. So I have no idea how to explain that, but those are the values. So here is the all-important Doom benchmark, and of course lower is better here because this is real ticks, not frames per second. And of course that ET6000 Hercules card is the slowest of the bunch again. There's a couple of others there that are a bit slower. There's the Cirrus Logic GD54M30 and the Trident TGUI 9440. But otherwise they're all very similar speeds, and I doubt you'd notice the difference between any of these. So I thought I'd finish with some Quake benchmarks, and these are at 320 by 200. I don't think there's much point in putting them up at high resolution anyway. They tell much the same story, and besides that, Quake would be unplayable on a 486 at a high resolution. It's marginal even at this resolution in my opinion. So the story is pretty consistent by now across all the benchmarks we've done. The good PCI video cards are just as good as the Visa Local Bus ones and vice versa. The only difference is that I had a lot more PCI video cards that just didn't work. There was either artifacting or they reset or there were beeps. Sometimes some of them paused every now and again. So I know that all of these cards are not faulty, by the way. I've tried them in other machines. So of course it's possible that I have a Brummy 486 board, or maybe it's just a bad model. It could also just be that VIA chipset. But it's also just as likely that early PCI implementations weren't that good. And the only video cards that I tried that didn't really have any problems with this early PCI implementation were the S3 ones. Remember, I tried 8 of these cards and they all worked perfectly without any issues, and they were top performers. That's actually good news because they're also very cheap and easy to get hold of. The only one that was a little bit slower was the S3 Trio 64, but even that was only a marginal difference. And if you think about the Visa Local Bus side, the Senglabs ET4000 W32 is a good performer, but remember it didn't run all the benchmarks, so even that I can't recommend 100%. Cirrus Logic ones are obviously also very good Visa Local Bus cards, and of course, as we saw last week, all of these are going to be much better than your average ISA card, at least in the implementation that I tested. So I think that's basically all of the conclusion that I can draw from all of this data. I had a lot of fun putting all of this together, and hopefully you enjoyed watching it as well. If you did, then please give it a like below and think about subscribing if you want to. That's basically all I have for today. So thanks very much for watching, and I hope to see you in a later video. Bye.